EKG. Resting cells of ventricular myocardium are minus 90 millivolt inside, means membrane is negatively polarized. If we introduce some cations like sodium or calcium, the membrane will be less negatively charged. Now suppose membrane is minus 90 millivolt. The threshold potential is minus 70, so now the sodium gate will open up in the membrane and sodium will come in. Eventually the threshold potential will go up till 0 and then plus 10. So we can say that because of the stimulation, cation come in and the membrane is now depolarized. Depolarization of the membrane will open up the potassium and calcium channels. Cells are rich in potassium, so potassium will start leaking toward outside and it's called potassium efflux. Now because potassium is leaking out, cell will go from positive 10 to 0 millivolt. Now the calcium will start coming in from its gates. Means when potassium or positive ion was leaking out, cell gained calcium and now the net change is 0, like the plateau phase. Up till now the graph was a spike from minus 90 to 0 and then positive 10. Now it came down to 0 and now it's gonna be flat line. As time passes, potassium will be moving out faster and now the graph will dip up till it reaches the resting potential, which is minus 90. It's called membrane is repolarized because of potassium efflux. Now the sodium which came in will trickle into the adjacent cell, make it depolarized, and then potassium and calcium channels will open simultaneously and the adjacent cell will repolarize due to the potassium efflux. This sequence of quote-unquote mobile sodium-potassium depolarization and repolarization is action potential. But remember, SA node and AV nodes are depolarizing. That means they are gaining calcium. Atrial myocardium is thinner than the ventricular myocardium. Myocardium is resting means all cells are negatively charged and no electric current is flowing. We stimulated, sodium gates open and sodium influx will make the cell depolarize and positively charged, and from gap junction this current will move towards the positive electrode. In galvanometer the needle will move toward the positive. Once all cells are positively charged, there will be no current. If we take vertical myocardium, which is thicker, now the current is stronger and is still moving towards the positive electrode. But if we stimulate myocardium from the positive electrode, the current will start flowing from the positive towards the negative electrode. During depolarization, sodium goes in and cell gets positively charged. During repolarization, potassium goes in and cell become negatively charged. Always remember, a last point of depolarization is going to be the first point of repolarization. When positive moves towards positive, deflection is always positive. When negative charges moves towards negative electrode, deflection is also positive. When negative or positive charges moves towards the opposite electrode, the deflection is negative. Purkinje cells in ventricles are bigger, have bigger gap junctions, and current can flow very fast through these cells. In a normal heart, electrical activity starts from the depolarization of SA node. Cells near SA node will undergo depolarization first. Atria will be depolarized downward and towards the left. Current will sweep simultaneously in right and left atrium with moderate velocity. This depolarization wave will hit the fibrous annulus, which is not a good conductor, so the current will only pass in the ventricle through AV node. In AV node, the conduction is slow and the depolarization of AV node takes about 0.1 second. This delay will make sure that atria are fully contracted. In AV node, the cells are small and towards the flow of the current. In Purkinje system, cells are large and that means fewer cells to cross to flow the current. So the current is gonna be really fast here. In AV node, the gap junction is small, while in Purkinje cell, the gap junctions are large. Depolarization of AV node is calcium dependent, while Purkinje system is sodium dependent. AV node cells resting membrane is minus 60 millivolt, while Purkinje system cells has resting membrane of minus 90 millivolt. AV node is very small and create very little vector, which EKG machine cannot recognize, so we say the heart is electrically silent. When current enters in the ventricle through bundle of His, first inner ventricular septum of the heart will depolarize, then major part of the ventricle and then the base part of the ventricle. From AV node, when bundle branches are coming down, they have fibrous insulators. Right bundle branches does not directly stimulate the septum. From the left bundle branch, when it comes down, it will depolarize the septum's lower part and the current will sweep from left to right and from down to upper part. Vector of the septum will be very small but very fast and towards the right and up. Now we have Purkinje cell adjacent to the myocardial cells. Subendocardial myocardium means most inner part of the myocardium, and subpericardial myocardium means most outer part of the myocardium. Left heart has more stronger current than the right heart. We can add both sides vector and show a single vector facing down and left. But from the basal part of the ventricle, the vectors are upward and down towards right. If positive electrode is towards the leg, while negative electrode is towards the right hand, when SA node fires, atrial positive vector is produced and needle will move up in galvanometer because up is positive and below is negative. Then it will neutralize, making a P wave representing atrial depolarization. Then AV node will fire, but because it is too low, we cannot see anything and we'll only see straight line. Now ventricular septum depolarization happens, where a short but fast negative vector is produced. This is Q wave. Now major ventricular depolarization will occur and a long fast vector R wave will be produced. When depolarization reaches the ventricle basal part, a small, negative but fast vector is produced. It's S wave. Now because the whole ventricle is depolarized, current is not moving, so the needle will show a straight line, and this is ST segment. Now the ventricle repolarization will start from the outermost part to inner part of the myocardium. Direction will be right and up and negative T wave. Repolarization is slower than depolarization. Waves. There are P, Q, R, S and T waves. Segments. There are PR isoelectric line segments and ST isoelectric line segments. PR interval starts at the beginning of P and end at the beginning of Q. QT interval starts from Q and end with T. It has both ventricle systole and ventricle diastole. In ventricle, papillary muscles can make U wave. These muscles make mitral valve close during the ventricular contraction. Within 1 minute or 60 seconds, 300 squares passes through the needle in the EKG machine. 1 square passes through 60 by 300, which is equals to 0.2 seconds. Each big square is divided into 5 more horizontal and vertical parts. One big square is equals to 5 small square. One big square is also equals to 0.2 seconds. So that means one small square is equals to 0.2 divided by 5 equals to 0.04 seconds. One small square is equals to 0.04 seconds. P wave takes 2.5 small squares or 0.1 second when heart rate is 72 minutes per second. PR segment is also 2.5 small squares or 0.1 second. PR interval will be 0.2 seconds. QRST complex takes 0.1 second or 2.5 small squares. From Q to T, it is 10 small squares